Hello, today we are looking at lesson 14, and this is sampling in a fair way. So, the first data that we have is a survey that was taken at a movie theater to estimate the average age of moviegoers. And we have a dot plot that shows the ages of the first 20 people who were surveyed. So if we look at this, we see we have people from the ages of 4 to 11 that were surveyed. Looks like a lot of our data kind of falls in this 8 to 11 age. So I'm wondering, what questions do you have about the survey? What questions do you have about the data from the survey? And what assumptions would you make based on the results? So pause the video and make a little note for each of these questions, and then push play again. Well, the first question that I'm having is, where are the parents? Because these are children. So were the parents not there? And then what about these younger children? So if there's younger children there, I'm thinking that must mean there's at least one G movie playing at the theater. I'm wondering why everyone is so young. I'm thinking there could be maybe a child's birthday party or something. So those are some thoughts that I'm having. And notice, just from seeing the results of a survey, I can start to have some thoughts and questions, and maybe even some assumptions and things that are probably true, just from looking at that piece of data. Okay, now we're going to look at some different methods that we could use for selecting samples. And if we were in a classroom together, then we would probably do this with a partner, and then for each situation we would actually take time to talk about this. But I'm just going to share some of my thoughts since we are doing this virtually and this is a video. So the first situation we have is Lynn, and he's running in an election to be president of 7th grade. And Lynn wants to predict her chances of winning. She has the following ideas for surveying a sample of the students who will be voting. So here's some ideas, and we're going to think about, would these different methods lead to different conclusions? What are the benefits of each method? What might each method overlook? Which of the methods listed would be the most likely to produce samples that are representative of the population? And can you think of a better way to select the sample? So as a reminder, the population would be the whole group, and then a sample is a small piece of the population that should be representative of the sample. So what if Lynn asked everyone on her basketball team who they're voting for? So that's going to be pretty convenient if she's asking the people on her basketball team. They're probably going to say they're voting for her because they're all on the basketball team with her. At the very least, they would want her to pass the ball to them. So probably going to say they're going to vote for her. Now, is that representative of the 7th grade? Probably not. It's going to overlook the people that are not on her basketball team, and that is a large bit of the population. So what about every third girl waiting in the lunch line? So if you're only asking girls, then that's biased. That wouldn't be a fair sample. If you're only asking students who are in the lunch line, that's also not fair, because you're leaving out that whole part of the population that does not get the school lunch. And the final one here is asking the first 15 students who arrive at school in the morning who they're voting for. Well, what about those tardy students? We all know from our first period there's a few students that are usually late. So we're leaving out that whole population there. So which of these methods listed would be most likely to produce samples that are representative of the population? Probably C, I would say. There are still some flaws with this, but it's kind of the best of the situations presented. And a better way, maybe just asking 3 people from each homeroom. That might be a very fair way to do this. And maybe you can think of some other fair ways, because that is our focus today, is selecting, sampling in a fair way. So, there's one situation. We're going to move on to another one now. And this one is on the next page. So, a nutritionist wants to collect data on how much caffeine the average American drinks per day. So our population is the average American. She has the following ideas for how she could get the sample. So she can ask the first 20 adults who arrive at a grocery store after 10 a.m. about the average amount of caffeine they consume. Well, I wonder if people who arrive at the grocery store after 10 a.m. all have something in common that people who arrive prior or later than that might not have in common. So I think if they're arriving at the grocery store after 10 a.m., they've probably, on one side you could say they slept in a little. On the other side you could say they get up early, depending on your thoughts on that. But it's definitely a particular group of people. And it's people who are at the grocery store. So you're leaving out all of the people that are working or all the people that are just home. So that's not really the average American. Now the next option would be every 30 minutes ask the first adult who comes into a coffee shop about the average amount of caffeine they consume. So if you're at the coffee shop, that is caffeine. So that's definitely going to be, you're going to get a higher number of people saying, yes, caffeine. We drink a lot of caffeine because we're at the coffee shop. So probably not a fair sample there. I think for this one, we're just going to have to think about how could we sample the average American? And maybe a good idea for that would be something along the lines of possibly surveying people at a different location, maybe the park or the mall, during the evening, so that it's not related to the morning and when we get up. Also, it's not a coffee shop, so it's not a place where people would likely have a predisposition to drink caffeine. Now, out of these two, because we're supposed to pick out of these two which one would be more fair, I think this is more fair out of the two, but it's still not really fair. I think there are other better ways, such as the mall or something that's not connected to when you get up or what you're drinking. So that's my thoughts on that. Now we'll move on. Okay, this next activity about the first straw, that this is another activity that would be best done in person, but this is your video, so I'm going to do the best I can with it. In class, I will have some straws in a bag, okay? For this, I just put them in a cup here. I've got this little cup that I put them in, and I'm just going to draw out 5 straws. So the activity, the instructions in my book say that we need to take out the first 5 that we touch. As soon as you touch it, you take it out. So 2, 3, 4, 5. Okay, there are my straws, and what I'm supposed to do is take a ruler and measure these to the nearest inch. Okay, half an inch to the nearest half an inch. So this one is right at 4. Okay, I'm just going to put that back in there. And the next one is, I'm just measuring these, starting at 0 there. This one's right at 5 inches. Okay, and this one also right at 5. This one is at 3. And this one is also at 3. Okay, and then I'll do the experiment again, and I will just record my results here at the bottom. Okay, so for time purposes, I went ahead and did the second one. Then I found the mean for each sample. They turned out to be 4 each. It was funny that they turned out to be the same, but they did. Now, were our estimates the same? Yes. Did the mean length of all the straws in the bag change between selecting the 2 samples? No, it didn't, because, I mean, I had the same set of straws, so it didn't change. Do you notice something down in there? Okay, so which straw am I most likely to touch? These tall ones? Or, I actually made a bag for each of the teachers. So, you can see, if I kind of spread these out, there's different lengths in here. Some of these are really short. And if I was drawing them out here, I mean, I'm not very likely to get these short ones. So the sample that I selected is not really representative of the whole set of data, because I'm more likely to get, when I first reach in, you have to take the first one you touch out. And I'm more likely to touch one of these longer ones first. So that goes down here with this. The actual mean length, and I cut these according to the instructions in the book, so the actual average of all these lengths is about 2.37 inches. So my estimates here were much larger because I was more likely to touch the longer straws first and draw them out. Now, if I repeated the same process again, but selected a larger sample, would my estimate be more accurate? And it probably would, just because these longer straws, see, the more that I take out, the more likely I am to get these shorter ones, because the longer ones would be gone. So it would be more accurate, probably still not extremely close to that, but it would be getting closer. So, on the back here, this is a continuation of that. So, there are 35 straws in the bag. What if we put the straws in order from longest to shortest, and then gave each straw a number? And then let's decide which of these would be a fair way to select a sample of 5 straws. So if they were in order from smallest to largest, shortest to longest, then if I picked straws 1 through 5, that wouldn't be very fair, because those are going to be the shortest straws. Now, what if I wrote the numbers 1 through 35 on pieces of paper that are all the same size, and put the papers in a bag, without looking, selected 5 papers from the bag and used those straws? Yes, that would be random. Nothing has one more chance of being selected than something else, so that is fair. I'm having a hard time thinking of anything that would be more fair. But let's look. Using the same bag as the previous question, select 1 paper from the bag. Use the numbers on that paper to select the first straw. Then use the 4 next numbers in order. So that wouldn't be fair, because what if I picked a 7? Then I would have 7, 8, 9, 10, 11, and those would all be very similar in length, and I would be, if I picked those, I would be leaving out the shorter ones and the longest ones. So, no. That's going to pick a select group there. Create a spinner with 35 sections that are all the same size and number them 1 through 35. Spin the spinner 5 times and use the straws with those numbers for your sample. Yes, this is random and this is fair. I think that is as fair as the other situation, which was the second one listed. So, excellent examples there for us to think about and talk about. Now, so this is how scientists used to come up with random numbers. Let's just read this. Computers accept inputs, follow instructions, and produce outputs. So they cannot produce truly random numbers. If you knew the input, you could predict the output by following the same instructions the computer's following. When truly random numbers are needed, scientists measure natural phenomena such as radioactive decay or temperature variations. Before such measurements were possible, statisticians used random number tables like this. Okay, so if I were going to use this table, I would start anywhere. I would pick a number. Okay, maybe I'm going to start here. Well, I need numbers 1 through 35. So these two numbers, let's see, 3. I've already got that one because these are straws. 1, 2, 3, 4, 5. So if that's the way that I was going to use this random number table, that's what I would do. Pick a starting point at random in the table. If the number is between 1 and 35, include that number of the straw in your sample. If the number's already been selected or is not between these, ignore it and move on to the next number. And that's what we did. So then our random sample, using the random number table, 24, 12, 15, 13, and 7. So that's kind of a fun fact and way that things used to be done. Here's a summary that you can read on your own. Then you have a problem set that you will need to complete. And that problem set actually has 5 questions. So I will make another video going over those 5 questions. So that way you can go over those after you've done them.